when things start moving, they have this thing called speed. And speed has a very specific definition. It's the distance that's traveled divided by how much time it took to travel. But guess what? Distance travel requires we have to measure it from some place, which kind of leads back to that coordinate system position stuff. And as I said, units are important. So let's look at units. For speed, since it's a distance divided by time, distance is measured, in meters in the metric system. Could be miles, okay? It could be furlongs. It's a distance number. Feet, inches, miles, whatever. Divided by a time unit. Seconds, hours, fortnights, whatever. So any valid unit for distance divided by any valid unit for time is a valid unit for speed. Now, most commonly, Tony, you probably do kilometers per hour when you're driving? You got kmh kind of going on where you are?
Yes, right.
Yeah, here in the States, it's miles per hour. George, down where you are you guys metric or US customary?
Yeah, we're part of the civilized world. We do metric.
Okay, all right, cool. All right.
Sorry.
Yeah, I'll pull that spear out of my side. Thank you very much.
I'm so sorry. No, we actually had a mishmash because we were part of the United States at some point.
Yeah.
So meat is measured in pounds. Distances is measured in kilometers. Fabric is measured in yards. Gas is measured in gallons. But milk is measured in liters. It's insane.
Oh man. So you get to work in both systems then.
It's like Esperanto.
How fun is that? All right. So, if you would, please, if you have your textbook, join me at example 9.1. Let's put some numbers together into this thing, okay? So in that problem, we're given that this car travels 78 miles. And it took 1.2 hours to do it. The question is, what's its speed, both in miles per hour and meters per second? Well, remember the definition of speed. It's the distance traveled divided by how much time it took to travel that distance. So in this case, we take our 75 miles, which was the distance, divided by our 1.2 hours. And if we pull out our handy dandy calculator, okay, get out our calculator, right? We turn it on, and we go 78 divided by 1.2 equals, and it turns out it's 65 is the number, and MPH stands for miles per hour. Pretty straightforward. But we're also asked to give the answer in meters per second. And so, Joe, now we got to do that conversion stuff. Okay? We got to convert meter, from miles per hour to meters per second. Okay? Here's how we do that. We're going to use those convenient forms of one. Okay? We know that there are 1,609 meters in 1 mile. So we can create this wonderful little fraction. 1609 meters over 1 mile. So that'll convert the distance stuff, but then I got to do the time thing. There's 1 hour equals 3,600 seconds. That's my convenient form of one. So let's pull it all together. I've got 78 miles over 1.2 hours. But then I'm going to multiply that by my convenient form of 1, 1609 over 1 mile. So do you see that I have miles on top with the 78 miles, and now I have 1 mile in the basement in the next fraction? Well, since I have a mile on top and a mile on the bottom, those units will actually fall out of the equation. Similarly, I've got hours in the basement, and then I've got that other form of 1 hour, 3,600 seconds. Notice how I have hours in the basement, an hour in the top. Those are going to cancel out. So I'm going to be left, once I do all the math on my calculator, I'm going to be left with an answer in meters per second. So in my calculator, I take 78 times 1609 divided by 1.2 divided by 3,600. Oops. I only hit divide once. 78 times 1609 divided by 1.2 divided by 3,600. Boom. Comes out to the 29.1 meters per second. But the car is still covering that same distance in the same amount of time. We just changed units.